Hi everybody, my name is Federico Noscentini, and in this video I will present our work, ScanTalk 3D Talkinets from registered scans. First of all, let me thank all of my co-authors, Thomas Besnier, Claudio Ferrari, Silvana Arguiller, Stefano Perretti, and Mohamed Daoudi. The task of 3D Talkinets is the development of a system that takes as input a 3D face and an audio file, and animate the face accordingly with the sentence spoken in the audio file. Current state-of-the-art methods are bounded with topology limitation. So the topology is the number and order of points that represent the 3D face. So current state-of-the-art methods are one model can animate faces in one topology. With ScanTalk, we developed a novel system that is able to animate 3D face in any topology with the same model, independently from the order and the number of points that represent the 3D face. Here we have the architecture of ScanTalk that is composed by an encoder and a decoder. The encoder is a concatenation of diffusion net blocks and for a per vertex Fisher extractor from the neutral face that we want to animate, and a concatenation of the UBERT, pre-trained UBERT audio encoder, and a bidirectional STM for audio Fisher extractor. Then we concatenate the Fisher, the per vertex Fisher extracted by the diffusion net blocks with the audio Fisher, and this concatenation is passed to the decoder. The decoder is composed with a mirrored version of the diffusion net blocks that are used in the encoder. The ScanTalk decoder outputs the per vertex displacement with respect to the neutral configuration, the neutral phase. Then we sum the neutral phase, and in this way we obtain the sequence of 3D Talkinets animated. Here we have an example of Fisher extracted by the diffusion net blocks in the ScanTalk encoder. In particular, we have two identities in different topology. So on the left, we have the same identity, but in three different topology, the same on the right. Here you can see that the descriptor have remarkable similarity in this, even if the topology is different. So this is why the ScanTalk framework is able to animate faces in any topology, because the descriptor are dependent only from the identity of the face and not from the topology. Here we have some qualitative results, and you can see that the three faces that we are animating here are in completely different topology.
The stale smell of old beer lingers.
It takes heat to bring out the odor.
A cold dip restores health and zest.
A salt pickle tastes fine with ham.
Tacos al pastor are my favorite.
A zestful food is the hot cross bun.
Buddy, you're a boy, make a big noise, playing in the street, gonna be a big man someday. You got mud on your face, you big disgrace, kicking your can all over the place, singing, we will rock you.
Yes, I know the Muffin Man, who lives on Drury Lane.
So here you can see that ScanTalk, the same ScanTalk model have been used to animate this 3D face. So ScanTalk is able to animate faces independently from the topology. Here we have three QR codes, one for the archive version of this paper, one for the GitHub repo of this work, and here we have a web page that describes the project. In this web page, you can find also other qualitative results and a brief introduction to the method. Thank you for your attention.